Hello everyone, welcome to memoneet. I am Aprajita, your chemistry SME. I hope all of you are doing good. So today we are going to discuss the solutions for your BPT 11. Okay, so here the chapter that is coming up in chemistry is coordination compounds. So all the questions are asked from coordination compounds in this chapter. So let us see what are the solutions of your BPT 11. So the first question means question number 51 is, which of the following complexes show geometrical isomerism? Okay, so geometrical isomerism may we have different arrangement of ligands, right? Basically we have this cis trans isomerism जिसको हम geometrical isomerism कहते हैं, we call it as geometrical isomerism. Okay, so it is actually possible in square planar complexes and octahedral complexes. So in octahedral complexes with formula mx2l4, where the two X ligands that we are having, they can be cis or trans to each other. Okay, so like in this question, the first option is an octahedral complex having this mx2l4 thing. Okay, 4H2O ligands and 2 chlorine. So you can see that here 2 chlorine are trans to each other, this is the trans isomer, and here 2 chlorines are cis to each other. So yes, this one is showing the geometrical isomerism. Next one is tetrahedral. So here tetrahedral complexes, they do not show your isomerism. Here three ligands are similar. Okay, then here all the ligands are same, it will not show geometrical isomerism. And in the fourth one also, it's five ligands are same, so it is also not showing the geometrical isomerism. So answer will be option number 1. Okay, next is question number 52, in which of the following complexes have splitting energy, that is delta naught, less than the pairing energy? So FeCN6 we have, FeNH36, FeEN3 and FeNO26. So students, you know that delta naught means your splitting energy, crystal field splitting energy, if it is less than pairing energy. So like if this is the splitting, this is the T2G orbital and EG orbital. So whenever delta naught is less than the pairing energy, okay, so it means the electron can easily, the splitting energy is less, so electron can occupy the EG orbital also. So the configuration will be T2G3 and EG1, means the fourth electron will not get paired up, it will go to the EG orbital. Okay, so the ligands, it actually depends on the ligands. So the ligands for which delta naught means the crystal field splitting energy is less than the pairing energy are called weak field ligands. Okay, so they don't let the pairing happen, they are weak field ligands and they will be forming high spin complexes. So if I look at the ligands here, we have cyanide, ammonia, ethylene diamine and nitro. So if we look at the spectrochemical series, ammonia will be the lowest one here and it will be forming the high spin complex. So it means the answer is option number 2. Okay, now moving ahead students, next question, match the following list with list 2. So here some complexes are given and we need to match with their hybridization. Okay, so in coordination compounds, knowledge of hybridization is also very important. So let's have a look at that. Okay, NiCO4. All right. Firstly, we'll be talking about nickel, tetracarbonyl nickel. Okay. So it is having 4 ligands. It will be having a tetrahedral geometry, but it is diamagnetic because in NiCO4, the oxidation state of nickel is 0. Okay, nickel is in 0 oxidation state and there will be no unpaired electron. The hybridization is sp3. It's forming a tetrahedral complex. Okay. Next up we have NiCN4 2 negative. Now in this case also we have 4 ligands with nickel, but nickel is having 2 plus charge. Okay, and there is a strong field ligand which is cyanide. So in this case, in Ni2 positive, all the unpaired electrons will be paired up and it will be dsp2 hybridized. Okay, so square planar geometry will be there and dsp2 hybridization will be there. Now COCN6 3 minus, it's an inner orbital or low spin complex. Okay, it has D2sp3 hybridization again. And COF6, so it is actually using your outer d orbital. So the knowledge is important ki whether inner or outer d orbitals are used. Okay, so for COF6 minus, 3 minus, there will be outer d orbital used, which is 4d, so it's an outer orbital complex and its configuration is sp3d2. Okay, so A1, B4, all right, C3, C3 is there, means D2 sp3 and D2. Okay, D2 is sp3d2, so that will be the answer, option number 2, C3 and D2. Okay, next question number 54. Among the following complex ions, one of having highest magnetic moment is. So now students, to find out the magnetic moment, you need to look at the oxidation state of the metals. Here it's Fe3 positive, here Fe2 positive, here cobalt 3 positive, and here also Fe3 positive. Okay, and that too you have to look at the ligand. So now in Fe CN6, Fe3 plus is there and it is D5. Okay, so it is having one unpaired electron. So students, you might be thinking, if it is D5, how come the unpaired electron is 1? Because cyanide is a strong field ligand, it will cause the pairing. Okay, like this. So what will happen, you will be having 5 electrons like this. So we are talking about Fe3 plus, no, so 5 electrons will be here and you will be having like this 5 electrons, and then you will be having 6 cyanide ligands. Okay, 1 2 3 4 5 6, D2 sp3 hybridization, so one unpaired electron is there. Okay, similarly in FeCN6, so here Fe2 plus is there, so it will be D6. D6 means there will be no unpaired electron, 0. In cobalt 3 plus, again D6, so there is no unpaired electron. And in Fe3 plus, now here fluoride is the, now this is the difference between FeCN6, okay, and FeF6. In both the case, the iron is in +3 oxidation state, but fluoride is a weak field ligand, so pairing will not happen and you will be having 5 unpaired electrons. Okay, 4 5 5 unpaired electrons will be there, so outer orbital complexes में बनेगा, outer d orbitals will be involved, so 5 unpaired electrons. So higher the number of unpaired electrons, higher will be the magnetic moment, so answer will be option 4. It will be having the highest magnetic moment. Okay, so knowledge about the ligands also is very important. Now question number 55. Again we have to match the compounds with their structures. Okay, decacarbonyl dimanganese. So decacarbonyl dimanganese, it's actually having 2 manganese atoms which are coordinated with 5 carbonyl ligands and forming 2 square pyramidal structures, and they are having a manganese, you can say metal bond is also there. So if I draw here, you can see 2 manganese, like one manganese bond is there, then there will be 5 ligands on each of the manganese atom like this. Okay, all right, so this will be the structure. Okay, so you can say 2 square pyramidal structures A3. All right, next up is hexacarbonyl chromium. Now chromium has 6 carbonyl ligands which are symmetrical, so they will be having octahedral geometry like we have. Pentacarbonyl iron has 5 ligands arranged, so again it will be trigonal bipyramidal with like 3 equatorial and 2 axial bonds like this. And nickel tetracarbonyl, they will be in tetrahedral geometry. Okay, tetrahedral geometry will be there. All right, so for nickel it's for chromium it's octahedral, for iron trigonal bipyramidal, nickel tetrahedral. Okay, D1 A3 B2 C4 D1, the answer is option number 2. All right, now moving on to the next question. Question number 56. Which of the following have following electronic configuration is possible for low spin tetrahedral complex? Okay, so low spin tetrahedral complex means Now students, what happens is for low spin complexes, the crystal field splitting energy is more than the pairing energy. So if I talk about the T2G and EG orbitals, so if the crystal field splitting energy is more, alright, so it means it will be favorable for the electron to occupy the T2G orbital only, means it will be starting to pair, okay. Instead of the fourth electron going to the EG orbital, it will go to the T2G only, and once T2G is filled, now then EG will be filled. Means the configuration can be T2G6, EG0. Okay. So this will be the most favorable configuration for low spin. Why we are calling low spin? Because here the electrons will be paired and the spin will be less. Okay. So these are strong field ligands and they form low spin complexes. So the configuration will be T2G6, EG0. Answer is option number 1. Okay. Next is question number 57. What is the magnetic moment and hybridization of the brown ring complex? Okay. So in brown ring complex, the oxidation state of iron is +1. Okay. So which is having D7 configuration, and in D7 configuration there will be again 3 unpaired electrons. Okay. 1, 2, 3, 4, 5. 6 and 7. So there will be 3 unpaired electron. So for 3 unpaired electron, the magnetic moment, you know, magnetic moment is given by n square root of n into n plus 2, means square root of 3 into 3 plus 2, which is square root 15 Bohr magneton. Okay, and the hybridization is sp3d2. Okay, outer orbital complex would be formed. So answer is option 3. All right. Now moving on to the next question, students. Question number 58. The correct IUPAC name of the compound, the given compound is. So here a compound is given to you. You need to find out the correct IUPAC name. Okay. Now just see here the compound given is COCl2, En2 and Cl. So this is the compound given to us in this case. So students, whenever we have to do this thing, the naming, we need to find the oxidation number of the metal as well. So here students, you can see that 3 chloride ions are there. So if I want to find out the oxidation state, so for chloride it's 3 into -1, and ethylene diamine neutral ligand, so it will be 0, and overall it's a 0. So X will be +3. So it means the oxidation state of cobalt is +3 here, because we have to write it in bracket. Okay. Now we are having chloride ligand, okay, and we are having ethylene diamine. So chloride will be written first because of the alphabetical order, and since it is chloride, so we will be writing it as dichlorido because 2 chlorine are there. Now ethylene diamine is a bidentate ligand, so we will be writing bis because there are 2 ethylene diamine, or we can write ethane 1,2 diamine. Okay, then we will be writing cobalt, and after that this chloride, which is after that, it will be the N ion, so it will be written after at the end. So cobalt 3 chloride will be the answer. Okay. Now question number 59. Correct increasing order of field strength of ligands is. So for answering this question, you need to just remember the spectrochemical series. Okay. So if you remember the spectrochemical series, you will be remembering the order. Okay. So firstly cyanide will be there, then it will be ammonia, then water, and then chloride. So second is the correct order. So if you remember this series, you can easily answer this particular question. Now consider the statement EDTA is used in the treatment of lead poisoning. Okay. Then we have statement 2. So this compound is known as Wilkinson's catalyst. It's used for the hydrogenation of alkenes. So yes, there are a lot of uses of your coordination compounds. They are mainly used as catalyst in different processes. So this rhodium complex, okay, it is used in the hydrogenation of alkenes. So this is true. Okay, and yes, ethylene diamine tetraacetate, EDTA, it is also used in the treatment of lead poisoning. So it means both the statements are true. Next question number 61. the inner orbital complex among the following is. Now again you need to find out which one is the inner orbital complex, means where the inner d orbitals are involved. Okay, so if the inner orbital, that like I told you 3d orbital it is used, we'll call it as inner orbital complex. So in the case of cobalt NH36, okay, if I talk about CO3 plus, now here it's 3 plus, so it's 3d6. Okay, now uh, in the case of ammonia, if we are talking about ammonia, there will be D2sp3 hybridization. Okay, D2sp3 hybridization, because it will be a low spin complex that will be formed. Okay, so here you can see the inner orbital complex is CONH3 6. Question number 61, answer is 3. Now the EAN, also we have to find out the EAN, effective atomic number, for FeCO5. Okay, so it is Z minus the oxidation state. So Z for iron is 26. Here the oxidation state of iron is 0, so minus 0. And for carbonyl there will be like 2 electrons. So 2 into how many carbonyl ligand? 5 ligands. So 26 plus 10, it will be 36. So effective atomic number for FeCO5 is 36. Now the geometry of NiCN4 and NiCl4 2 negative are. Now in this case, in both the cases, students, so although the oxidation state is same, but the geometries are different. If I talk about nickel Cl4 2 negative, so here the hybridization will be sp3. Okay, and it will be having a tetrahedral geometry. 3d8 is there na, so 3d8 में यहाँ पर no pairing would take place because chlorine is a weak field ligand. Okay, 1 2 3 4 5 6 7 8. So this is your 3d orbital, and then 4s and 4p. So here these 4s and 4p will combine to form sp3 hybrid orbitals, and you will be getting sp3 hybridization and tetrahedral geometry. But for NiCN4, now what will happen? I will show here only. So here now pairing will happen because cyanide is a strong field ligand. So this electron will be paired up and you will be getting dsp2 hybridization for the cyanide. Okay, for nickel CN4. So it will be having a square planar geometry because its hybridization is dsp2. Okay, so it is been explained in detail in your NCRT also, so keep that in mind. Okay, you can like see it from there. So answer is option 2. Next, question number 64. Which one among the following is a heteroleptic complex? So students, you know, in the complexes where only the metal is bound to one kind of donor groups only, it is known as homoleptic. And where the metal is bound to more than one kind of groups is known as heteroleptic. So in this case, the heteroleptic compound is option number 3. Okay, because there is chloride also and phosphine also, so that is your heteroleptic compound. Triphenyl phosphine is there, no? Okay, question number 60, fine. 5, you have to match the ligand with the type of ligand. So we are having triphenyl phosphine, so it will combine with the phosphorus atom only, so it's a unidentate ligand. Okay, for A it's a P. Then BF3, now BF3 boron trifluoride, it's an electron deficient molecule because only there are 6 electrons around the central atom, so it will not be acting as a ligand because it is itself is a electron deficient compound. So how it can donate electrons, right? So not a ligand. B is R. Okay, so these two options cancel. A, P, B, R. Then ethylene diamine, it's a bidentate ligand. Okay, means there are 2 nitrogen atoms through which it can bind, so it's a bidentate or didentate ligand, you can say. Bi or di, one and the same thing. Ethylene diamine tetraacetate, it's a hexadentate ligand, EDTA4 minus now, because there are 2 nitrogen atom and 4 oxygen atom through which it can bind. Okay, so for C it's Q and for D it's S. So answer is option 3. Okay, next. coordination number and the oxidation state of element E in the complex is where En is ethylene diamine. So you have to find out the coordination number and oxidation state of E. So the compound is like this. Ethylene diamine is given C2O4, okay, and NO2 is there. All right. So we have two bidentate ligands in this case, ethylene diamine and C2O4. So the coordination number will be 6. Okay, 6 is the coordination number because we have two ligands, two bidentate ligands. So 2 into 2, 4 and plus 2, 6. So now if we take the oxidation state to be X, so for X and plus, so for ethylene diamine it's 0 and minus 2 equals to 1. So yeah, that we can take. Minus 2 for this thing, your C2O4, and NO2 ke liye minus 1. So X will be plus 3 from here. Okay, so oxidation state is plus 3 and coordination number is 6. So answer is option 4. Now assertion NF3 is a weaker ligand than NCH3 thrice. NF3 ionizes to give fluoride ions in aqueous solution. So students, it's correct that NF3 is a weaker ligand than NCH3 thrice because fluorine is an electronegative atom. Okay, it is highly electronegative, so it withdraws electron from the nitrogen. So if it can withdraw electron from the nitrogen, so the lone pair of nitrogen cannot be ligated, it cannot be donated, right? While NCH3 thrice is a strong ligand because there are 3 CH3 groups attached and CH3 are your electron donating group. So they will increase the electron density of nitrogen on the nitrogen and it will be easy for nitrogen to donate the electrons. Okay. So in this case, the answer is assertion is correct, reason is incorrect because NF3 will not ionize in this case. Okay. Next is the complex given is. So there is a complex given to you and moreover it's a non-superimposable on its mirror image, means this is an optically active compound. Okay, if it's an optically active compound, it will rotate the plane polarized light. Okay. So it means it's non-superimposable, optically active and rotate plane polarized light. So answer is option 3, that is 1 and 3 are correct. Next is question number 69. Again we need to tell the type of isomerism given by these compounds. So the first compound, again it's an octahedral compound having Ml4x2 type compound. So it will be showing geometrical isomerism, that is the cis-trans isomerism. Okay, so for A it's S and for AS only one option is there, but we will see others also. Then cis cobalt, ethylene diamine and chloride is there, so it will be an optically active compound. Okay, because it's non-superimposable on its mirror image. So from here it shows optical isomerism. Okay, so here now the next one is C. Now in C chloride is there, okay, out of the coordination sphere, so they will be your ionization isomers. All right, and the last one is the coordination isomer. Okay, because the ligands can be interchanged. Here the ligands can be interchanged, so it's a coordination isomer. The answer is option A. Okay, question number 70. Next question. Among the ligands ammonia, ethylene diamine, cyanide and cobalt, the correct order of increasing field strength. Again you need to find out the increasing field strength for the ligand. So you need to know the spectrochemical series. Okay, so if I talk about ammonia and ethylene diamine first. So ammonia is weaker than ethylene diamine. Then cyanide will come and then at the last carbonyl, which is the strongest one. Okay, so yes, the answer is option number 1. All right students, next assertion FeCN6 4 minus, it's weakly paramagnetic while FeCN6 3 minus is diamagnetic. FeCN6 3 minus has +3 oxidation state, and this one has +2 oxidation state. Okay. So if I talk about FeCN6 4 minus, okay. Okay everyone, so here it has to be FeCN6 3 minus and FeCN6 4 minus, because if I talk about FeCN6 4 minus, so here it's iron, it's in +2 oxidation state, means D6. Okay, if I talk about D6, 1 2 3 4, okay, 6, and then S and P. So what happens in the case of cyanide, this pairing would happen and you will get D2sp3 hybridization, pairing will happen. So it is a diamagnetic substance, okay, because there is no unpaired electron. So CN6 4 minus is diamagnetic. If I talk about CN6 3 minus, तो यहाँ पर there will be Fe3 plus, so 5 electrons, and 5 electrons में when pairing will happen, so 1 2 3 4 5, so there will be this one unpaired electron, then D2sp3 hybridization will be there. So yes means Fe, both assertion and reason are true, and reason is the correct explanation of assertion. It's answer 1. Okay, so that will be this case, because plus the oxidation state hai, it has having unpaired electrons, so it's correct. Okay, question number 72, correct order of magnetic moment. So again you have to find out the oxidation state and then find out the number of unpaired electrons. Okay, so FeCN6 4 minus, so again here iron is in +2 oxidation state and pairing happens, so 0 unpaired electron. In COCl4 there are 3, and in MnCl4 2 negative there are 5 unpaired electrons. Okay, so that is the order, and the magnetic moment will be highest for manganese ones, okay, then COCl4 and then FeCN6, because higher the number of electrons, unpaired electrons, higher will be the magnetic moment. Question number 73, the d electron configurations of chromium 2 positive, manganese 2 positive, iron and cobalt 2 positive are given. Which one of them will be exhibiting minimum paramagnetic behavior? So again you need to see the number of unpaired electrons, then give the answer for this particular question. So students, chromium 2 positive is D4, okay, and if D4 is there, there will be 4 unpaired electrons. For manganese 2 positive, it's D5, 5 unpaired electron. Fe2 positive is D6, 4 unpaired electron. Cobalt 2 positive is D7, 3 unpaired electron. Okay, so minimum paramagnetic behavior will be exhibited by cobalt because it is having the minimum number of unpaired electrons. Okay, so answer is going to be option number 3. Okay, next question 74. Correct statements for the following complexes are, so MnCl6 3 minus and MnCN6 3 minus. So magnetic moments are given. Okay, so magnetic moment is yes 4.8 and 2.8 respectively. So this one is true. And inner sphere and outer sphere complex. Okay, so if I talk about MnCl6 minus, so it is sp3d2 hybridized, means it's an outer sphere complex, and MnCN6 3 minus, it's inner, so this is wrong, and this one is correct, sp3d2 and d2sp3, so means both A and C are correct. Okay, next, Cn minus is a strong field ligand. This is due to the fact, so students, you know it is a strong field ligand as it is a pseudo halide ion. These ions are strong coordinating ligands and they have a tendency to form sigma bonds, okay, from the pseudo halide to the metal, and pi bond from the metal to pseudo halide. So that is why it is a strong field ligand. So answer is option number 2. Okay, next question 76. Due to the presence of ambidentate ligands, coordination compounds show isomerism. Palladium complexes of the type are, so we need to tell what kind of isomerism they are showing. Okay, so thiocyanate can bind to the metal. This is thiocyanate ion. It can bind to the metal through nitrogen or through sulfur. Okay, so means they can link to the metal in two different ways. So yes, we will call them as linkage isomers. The answer is option 1. Okay. Next is question number 77. The color of the coordination compounds depends on crystal field splitting. What will be the correct order of absorption of wavelength of light in visible region for these compounds? Okay. Now strength of ligand increases as crystal field splitting energy increases. So you know that cyanide is the strongest. Then here it's ammonia and then water. So if the energy separation is more, means if the crystal field splitting energy is more, the wavelength will decrease. Okay, means the least wavelength will be, means the least wavelength will be for the cyanide, then for ammonia, and for water it is going to be the maximum, because the crystal field splitting is minimum for water. Okay, so the answer is option number 3. All right, question number 78. So these two compounds are given to here you. These are the, now you know the complex in which metal is bound to only one donor group is homoleptic. Okay, so this one is an homoleptic compound, and the other one, because here ammonia and chloride are both of them are there, so more than one kind of donor group is there, so it's an heteroleptic compound. Okay, so answer is option number 3. Question number 79, students, in the octahedral complex. So there is this octahedral complex given to you. Cobalt is in +3 oxidation state. So this is true because here if I find out the oxidation state of cobalt, so yeah, it is X plus 0 is equal to 3. So yes, X is equal to 3 because for ammonia it's 0, charge is 0. It is in 3d6 configuration. So yeah, you can see if cobalt 3 plus is there, so it will be 3d6. Diamagnetism exists. So yes, ammonia being a strong field ligand, it will cause pairing of these electrons. Okay, so pairing will happen, 3d6 they will get paired up, and d2sp3 hybridization will be there. So it means all the three statements are correct. It is a diamagnetic compound because pairing is happening. Okay, question number 80. The assertion says octahedral geometry and diamagnetism exist in CONH36. Just now we have seen ki yes, diamagnetism is there because 3d6 is there and pairing will happen. And since 6 ligands are there, yes, octahedral geometry is there. Reason is it has no unpaired electron. This is also true. So because of no unpaired electron, yes, diamagnetism exists. So both the statements are true, means both assertion and reason are true, and reason is the correct explanation of assertion. Next question, students. Sum of the coordination number and oxidation number of metal M in the complex is, so here a complex is given MEN twice C2O4. Just now we have done a similar kind of question, and chlorine. Now C2O4 2 minus, you know it's a bidentate ligand and it has a -2 charge, and ethylene diamine, it's also a bidentate ligand, carry 0 charge. Okay, so if I talk about the oxidation number, so for metal you can take it as X, then 2 into 0 for ethylene diamine, then -2 and -1 for chloride. So it's X minus 3 equal to 0, so X equals +3. So +3 is the oxidation number. Okay, and now the coordination number will be 6 because they are both bidentate ligands. So 4 for ethylene diamine and 2 for here. So total there will be 6 coordination numbers. So 6 plus 3 is 9. The answer is option A. Which of the statement is true about COCN6 3 minus? Now just now if we did for cobalt, this one now NH3, now we can do for cyanide. Now again here the oxidation state of cobalt is +3. Okay, because X plus 6 into -1 is -3, so X is equal to -3 plus 6, which is plus 3, and plus 3 means it is 3d6 and it is a strong field ligand, so pairing will happen and it's a low spin complex diamagnetic. So from here you can say 4 unpaired electrons. This is wrong. Again 4 unpaired electrons, wrong. It has no unpaired electron, okay, and it is a low spin complex. So answer is option 4. Okay, if no unpaired electrons are there now, so the compound is your low spin complex. Now, which of the following forms a set of complex and double salts? Okay. So the first one, this is K2 platinum NH3 twice Cl. It's a complex salt because there is a coordination entity. Okay, and the next one, it is a potash alum, which is your potash alum. Okay. So it is a double salt because it can dissociate into its ion. So the answer is option number 3. Okay. Next. Ethylene diamine tetraacetate, which is your EDTA, it's what kind of a ligand? So if you look at the structure of EDTA, it's a hexadentate ligand, means it can combine from 6 sides. Okay, 4 oxygen and 2 nitrogen. You can see here 4 oxygen and 2 nitrogen donors are there. So it is a hexadentate ligand. The answer is option number 2. Next, question number 85. You have to write the IUPAC name of the complex. Okay, so how to determine? So there is a cationic as well as the anionic part. Now H2O is a neutral ligand. So the first part is cationic and cyanide is a negative one. So it's an anionic. Okay. So first of all, we will be writing the cationic part. Okay. And the sequence will be prefix for the ligand, then the ligand name, central metal ion, and then oxidation number. Okay, and after that the anionic part, it is named with 8 at the end. Okay, we will write ATE at the end and then oxidation number will be written. Okay, so the answer is going to be diaqua because there are two this thing water now. So diaqua will be there, 2 aqua, silver, and here the oxidation state of silver will be +1. Okay, so 1 in the bracket. Then we will be writing dicyanide, and now you have to put 8 now, so you will be writing argentate and it's 1. All right, so the answer is option number 4. Okay, all right. Moving on, students, question number 86. Which complex compound is most stable? Okay. Now what happens is, here we'll be applying the chelation effect. So chelation effects refers to the enhanced affinity of a ligand when it forms ring structures by coordinating with the metal ion at 2 or more points. Means whenever the ligand is bidentate, means it can combine at 2 at more points. So this is known as a chelate complex, and this complex which has ethylene diamine in it, it is stable because of the chelation effect of ethylene diamine, because it's a bidentate ligand. So whenever the chelation is there, okay, the compound would be stable. So answer is option number 2. Now it's 87. The order of energy absorbed which is responsible for the color of the complexes is, okay, now here ethylene diamine, it's a bidentate ligand, so it can bind through like 2 nitrogen atoms. Okay, so that's why we are calling it as bidentate ligand. And now you know crystal field splitting, again it depends on the strength of the ligand. Okay, so if you want to look at the strength of the ligand, you can see the spectrochemical series. So you know ethylene diamine is a strong field ligand. All right, and the order of the energy will be C, then A, then B, means ethylene diamine, because here there are 3 ligands attached now. So 3 ligands attached, so it means it will be having the strongest field, so C. and then it will be where two ligands are attached, and then where one ligand is attached. Okay, one ethylene diamine. So stronger the strength of the ligand, higher will be the energy absorbed. So the order is CAB because of the number of ethylene diamine ligands that are attached here. Okay. Question number 88. Again, there are some complexes. We have to find out their magnetic moment. So you need to see the number of unpaired electrons in FeCN6 3 minus. 3d5 is there. Okay, unpaired electron is 1 because cyanide is a strong field ligand, pairing will happen. So find out the magnetic moment using this formula, square root of n into n plus 2. So it will come out to be 1.7. Similarly, you can do it for the other ones. Okay. So when you will find the values, you will see the number of unpaired electrons, put the values. So answer is going to be option 3A4 P1. Okay. C2. Because here iron is in +2 oxidation state and it is having no unpaired electrons. So if there are 0 unpaired electron, so it means this thing, your magnetic moment will be 0. And for the last one, it's 4.9. Next question number 89. Students, which of the following is the correct order of increasing field strength? So again, increasing field strength, look at the spectrochemical series. Okay, so thiocyanate is there, SCN is there, fluoride is there, cyanide is there, and C2O4. Okay, oxalate. So just look at this order. So it will be thiocyanate, then fluoride, then C2O4O minus, and then CN minus. Okay, so the order is option number 4. This is the correct order. All right. Now next is, what is the correct electronic configuration of the central atom in K4 FeCN6 based on the crystal field theory? Okay. Now if I talk about FeCN6 is there na, K4 FeCN 6 means iron is in +2 oxidation state. +2 oxidation state means 3d6. Now 3d6 is there, and in the presence of your 6 strong field ligands, which is the 6 cyanide ligands are there, which are your strong field ligands. So what will happen? Pairing will happen and it will be T2G6 Eg0. Because pairing will happen because of the presence of 6 strong field cyanide group. So T2G6 Eg0 means question number option number 2 is the right answer. Okay, so this one is the correct answer, students. Next question number 91. The correct spin only magnetic moments of COF6 3 minus and COC2O4 3 minus are that we have to calculate. So again, you know, magnetic moment is given by the formula n into n plus 2. So you need to find out the number of unpaired electrons in the complex. So for COF6 3 minus, here the cobalt is in +3 oxidation state. Okay, and here means so it will be 3d6. Moreover, fluoride is a weak field ligand, so no pairing would happen, and if no pairing would happen, so you will be having 4 unpaired electrons. So 4 unpaired electrons means the magnetic moment you can calculate square root of 4 into 4 plus 2. So it's coming out to be 4.89 Bohr magnetron. Okay. Now in the case of C2O4 thrice, okay, here also students, it's CO3 plus, but again it's a strong field ligand, so pairing would happen 3d6 and there will be no unpaired electron. If no unpaired electron means the magnetic moment is 0. So the answer is option number 3. Question 92. Calculated spin only moment for chromium 2 plus. Again chromium 2 plus, students, it's 3d4, okay, because chromium is 3d5 4s1, no? So chromium 2 plus is 3d4 and 4 unpaired electrons. So 4 unpaired electrons means square root of n into n plus 2 you will do. So it will come out to be 4.90 Bohr magneton again. Now question number 93. Metal carbon bond and metal carbonyl possess both sigma and pi character. Yes, the ligand to metal is a pi bond and metal to ligand is a sigma bond. So you have to choose the right statement. So students, actually, yes, in the case of metal carbonyls, it has sigma and pi bonds both. So जो ligand to metal bond है, it's a sigma bond, all right. And then metal to ligand is the pi back bonding, which is called the synergic bond. So assertion is true, but reason is not true, because ligand to metal will be a sigma bond and metal to ligand will be a pi bond. So answer is option 4. Assertion is correct, but reason is not correct. Next is 94th question. You to find out the incorrect statement. Okay, so oxidation state and coordination number of aluminium in this complex is +3 and +6 respectively. So yes, you can see there are 6 ligands attached, so the coordination number is +6. And if you want to find out the oxidation state, so aluminium clay you can take X, and for chlorine -1, H2O के लिए 0, it's +2. So yes, X will come out to be +3. So this is true. Na2O is a basic oxide, Cl2, 7 is an acidic oxide. So yes, you know metallic oxides are basic in nature, whereas non-metallic oxides are acidic in nature. This is also correct. Following 4 species are isoelectronic. So yes, O2 negative means 8 plus 2, 10 electrons. Fluoride also has 10, sodium 10. So all of them are having 10 electrons. This is true. Among the 4 species, Mg2 plus and Al3 plus, the smallest one is aluminium. So students, you know, the smallest one will be the aluminium 3 plus, because whenever cation is formed, the size of the cation is smaller than the neutral atom, because there will be high nuclear charge pulling the electrons close to the nucleus. So among Mg2 positive and Al3 positive also, there will be here 3 electrons are lost, so it will be having more nuclear pull and the size will be least. Okay, next is select the element M whose trihalides cannot be hydrolyzed to produce ion of this form. So the answer in this case is boron. Okay, we have gallium, indium, aluminium and boron. So boron trifluorides like BF3, BCl3 and Bi3, they cannot be hydrolyzed to form this type of ion, because boron does not have the d orbital. Okay, there is no d orbital and it cannot form octahedral complex. Okay, because here we have 6 water ligands na, so 6 ligands will be attached only when there is an d orbital. So no octahedral complex would be formed. To question number 96. Choose the correct answer from the options given below. Again, you have to find out the hybridization. So NiCN4 DsP2 hybridization, square planar shape, COF6 sp3d2 octahedral. Okay, COC2O4 thrice DsP T2sp3, again it's an inner orbital complex. Okay, because pairing happens. And NaCl4, it's tetrahedral sp3. So answer is 1. A4. Okay, DsP2 B3 C2 and D1. Question number 97. Again, you have to match the given complexes with the isomers, isomerism, type of isomerism you have to tell. Okay, for the first one, it will be showing the optical isomerism, cis-trans isomerism. The second one will show, I think the question is repeated, right? This question is done already. So it will be showing optical isomerism. Okay. Next one shows ionization isomerism, because they can interchange the ligands. The chlorides are outside the ionization sphere, and here exchange of ligands can happen. They show coordination isomerism. So it's option D. Among the following pair of complexes, in which case the delta naught value is higher for the first one. Okay, so you know that higher crystal field splitting is for the strong field complexes. So out of ammonia and cyanide, cyanide is strong field, so here it will be having the more value. Out of fluoride and ammonia, fluoride is there. H2O6, it's same here. Okay. and for here also we are having H2O. Okay, so here we are having rhodium and here we are having cobalt. Now central metal ions, here they have same oxidation state, which is +3, and the ligands are also same. Okay, so what will be doing here? Now rhodium 3 positive will be having higher effective atomic number, Z effective, than CO3 positive. So it will be having more delta naught value. Okay. Next is consider the following statements. In coordination compounds, metal show two type of linkages. Yes, they can show two type of linkages, primary and secondary valencies. Okay, so primary valencies are ionizable and satisfied by negative ions. So this is also true. The answer is both the statements are true. Next, classify the structures into nitrito, nitrito O, and thiocyanato C, and isothiocyanato D. Okay, so nitrito is when the linkage happens from nitrogen. So this is nitrito N. Okay, this one is nitrito O. Then thiocyanato. Thiocyanato is when the linkage is through sulfur. And this one is isothiocyanato. Okay, so from here A is nitrito N. So fourth A. Okay, 4A. Then for first के लिए देखते हैं nitrito O. It's B. So option 2 will be there now. Yes. So option 2 is going to be the right answer. So students, with that we have completed the solutions for the chemistry section. I hope all the questions are clear. So see you in the next BPT video solution. Thank you so much. Take care.